Hello, everyone. Let's see. All right, so yeah, welcome back to another episode of web development. So we are in the second half of the course, and in the first half, we mostly discuss creating a user interface, right? The client side of a client-server web application, right? That was built on React.js, right? A JavaScript library that could dynamically render a user interface, right? And we identified some limitations, right? That we had some limited access to the internet. We couldn't have access to the file system. We couldn't make permanent changes. And so this time around, in the second half of the semester, we are building a server, right? The server side of a client server application where the user interface can delegate a lot of the things, a lot of the limitations that are fundamental because we're using a browser, right? That it's running in somebody else's machine, and for security purposes, it's limited on the resources that it has access to on your machine. It delegates a lot of the this work of being able to store things permanently and access resources and the file system, the operating system in general. We're delegating it to a server, right? It's a process that um, you know it can be executed right from the console. It's not running in a browser, so it doesn't have any of the limitations, right, of a browser, right? It can have access to the entire operating system, connect to databases and whatnot, right? And but we need to integrate these two things, right? We need to integrate these two sides of the same application, right? We mostly discuss the front end for the first half. The second half, we're focusing on building an API, right? An interface that can expose URLs, right? That can receive HTTP requests from the client, right? And so that the client can then do some of the work that we can't do on the browser side. Okay. For in the last lecture, we discussed on some lab exercises, right? We practiced some skills, uh, some fundamental skills that we need to learn, right? Of how to create routes, how to create how to receive messages or data from the client, right? That we can either encode them in the URL, we can part of the query string, or pass around entire JSON objects to the server, and then the server can then parse all this data, right? So that it can do the work, right? So we're gonna expand on this, right? We're gonna keep going. We're going to take a look at you know, using many of these skills, right, and then putting them to work for keep working on our Kanbas application, right, our online learning management system that's it's inspired on the very popular Canvas online learning management system, right? And so one of the things we need to do is, for instance, uh, be able to support authentication. Folks need to be able to identify themselves, right, log in, register. They have their own profile. Right? So today we're going to explore that. How is it that we can implement these features? In particular, in client-server applications, right? It has you know an additional complexity in that we this application, this web application, typically are meant to be used by lots of folks, right, simultaneously. Right? It's not just one person using the application. You can have dozens, hundreds, thousands, right, of users simultaneously using the same application. Just imagine how Canvas works, right? I log in, you guys log in, everybody logs in simultaneously, and we collaborate, right? I post some work, some assignments, some quizzes, and then you go in and you consume that content. Well, similarly, right, we need to be able to support that kind of thing, right? The application needs to be able to keep track of everyone, simultaneously having a conversation with the applicant. It's one application, right, hosting one content that is being consumed by dozens, hundreds, thousands of people simultaneously. And so this introduces the complexity of, how is it that the application knows who you're talking to, right? Uh, in the at a minimum, you would have a single server, right, that is hosting the application, and then you have multiple browsers that they're all talking to the same server, right? So this server needs to be able to multitask, multiple conversations simultaneously, being receiving all these requests, posts, puts, deletes, get requests, from dozens, hundreds of browsers that are talking to the same server, right? So that's we're going to be discussing that today, right? It's referred to as session management, right? The server needs to be able to maintain you know a particular conversation, right? That is it's private, right, with that particular person, but more generally, it needs to be able to distinguish where the request is coming from, right? In particular, because HTTP, by design, by the architecture of the HTTP communication protocol, doesn't have uh, any identity. There's no identifiable information in the request, right, that distinguishes one user from another user, right? So from the server's point of view, right, all these requests that are coming in, right, are all the same, right? You can't distinguish between them. So on top of that, right, there has been several alternatives of how is that we can maintain, right, a conversation, individuals identifying themselves and whatnot, right? So today we'll discuss the main mechanism by which we can do that, which is maintaining cookies, right, and creating sessions on top of the cookies architecture, right, on how is it that folks can maintain identity. Other things that we're going to get to today is that all the data that we have been working on, on the client side, on the user interface, right? We've been playing around with creating courses, creating modules, assignments, and whatnot, right, on the browser, and and uh, and it's it works pretty well, right? We can create content and whatnot, but when you refresh the screen, right, all those changes go away. So there hasn't been a mechanism for us to permanently make those changes permanent. So we're going to move all that data, right, of courses, modules, and whatnot. We're going to move it over to the server side, right? And that means that, right, all the mechanisms for manipulating that data, of sharing that data, updating, deleting, CRUDing, create, read, update, and delete of this data needs to be, supported on the server side, right? So that each one of these data sets, right, of modules, assignments, quizzes, and whatnot, right, they need to be wrapped around an API that allows us to do all those operations on each one of these data sets, right? So yeah, so lots to work on. Really cool stuff too that we're going to be discussing this week. So let's get started. Also this week, right, you should be working on the fifth assignment. We discussed the lab exercises last lecture. Today's lecture, we're going to work on the second half of that assignment, how to start working, using all those skills from last lecture, but right in the context of building the Kanbas application. Okay. Also, the quiz should be available. Again, it's online course, so it should be available all week. So find a 20 minutes to take the quiz. All right. Okay. All right. So let's talk about how is that we can maintain sessions, right, in using Node.js. Now, what we mean by sessions is that you have multiple browsers, right, simultaneously trying to talk to a single server, right, or maybe a handful of servers, right, and these servers need to be able to receive these requests, perhaps spawn additional processes that run on that one CPU or maybe a quad, or 8 CPUs, and then spawn these instances that handle, right, in a multi-threaded environment, be able to handle all these requests that are coming in from from multiple browsers, right? And servers are designed to do that, right? They already come out of the box, to be able to do that. The question is, okay, well, even if you can do that, if how can the server distinguish an incoming request from another incoming request? Because HTTP by design is a stateless protocol, right? Meaning there's nothing in the communication that uniquely identifies one user versus another, which is not quite true because you do have the IP address of the machine that is coming. So perhaps you could tie the session to the IP address, right, or the MAC ID of the machine that the request is coming in from, right? But that's part of the request object, right? Not necessarily part of the HTTP protocol, right? So we need to create a mechanism that is built on top of HTTP, right? That can support this type of conversation between servers and multiple users simultaneously, right? So the main mechanism is called cookies, right? It's nicely visualized in an iconic movie, the Matrix, which I'm sure you're familiar with. And that's when Neo is wants to talk to the Oracle. You'll remember that the Oracle would not speak to Neo, right? Would not yet, right? Until Neo accepted the cookie from the Oracle, right? So there's this kind of a protocol. In this case, is a social protocol between two people, right? That it's sharing some nice sweets, right? That the other person who's requesting to have a conversation, right, needs to accept the trust, right, of consuming some some food, right, to establish this trust, right? And then once Neo accepts the cookie, right, the Oracle will then talk to Neo. And so the mechanism is as follows, right? What the general idea is that because HTTP on its own, does not have any identifiable information that the server could use to distinguish between multiple users, right? We need to build something on top of that, right? And that mechanism is basically the server and the browser are going to agree, right, that that the server is going to generate a unique identifier, right, a UUID, right, that only the server knows what that ID is, right, and it knows that it generated it. Okay, it can keep track, right, that it indeed has generated this ID, and only that server could generate that ID, right? And then when a browser comes in and wants to establish a conversation, right, the server provides this identifier, and the browser can agree, right, to now keep track of this cookie, of this unique identifier, and then in each subsequent request, right, that it would provide this identifier, right, in every subsequent request. And then the server could then use this identifier and say, oh, now each individual, Alice and Bob and Charlie and Dan, each one's going to have a separate unique identifier. Next time you come to me, right, I can identify you, I can look you up, right, and then know that it's you again, right? Now, on top of that basic mechanism, right, we can build all sorts of infrastructure, right, including what we refer to as a session, right? A session is an instance, an object instance, right, that the server can maintain, in memory, right, mapped to that unique identifier. Okay, and it can retrieve this data structure, right, per identifier, right, so that, right, if I'm talking to Alice, Alice has their unique identifier. I can always look up Alice's unique, right, data structure that is tied to Alice's identifier. If Bob comes in with a different identifier, Bob will have a different data structure tied to that unique identifier. Okay, this data structure is what we refer to as the session. Okay, now this session can be provided to the application, the running application, that can use this session for storing data, retrieving data, right? That data that we can store and retrieve into this data structure, it'll be specific, right, to that conversation from that unique identifier, from that unique user, right? So for instance, we can store in there, say, a shopping cart, right? A running shopping cart of the things that Alice likes, right? And she's been adding information into the shopping cart. If Bob is adding or removing items from his shopping cart, then it'll be his shopping cart, right? Each one can have, its own, data structure, right, of arrays or linked lists or whatever you want to store in there. Your application logic will decide what it is that you want to store in there. Okay. Now, obviously, typically, none of this data would be actually stored in a session object. Typically, all that information would be actually stored in a database, right? More likely, what we're going to store in this session information is identifiable information, right? On like account information, right? That uniquely identifies people, right? That I have logged in. You have stored in the session the fact that I have already logged in. I've already identified myself, so that subsequent queries that navigate to multiple screens, right? The server can treat me as a known person, right? Who has already identified, right? The first time around, right? When I come in and I have no session object, right? The server will say, well, I don't know who you are. I will challenge your identity. Tell me who you are. You log in. Once you log in, we can establish and store, right, in the session the fact that you have already logged in. I know who you are, right? So that every subsequent request, I can go to this data structure session and see that you have indeed already logged in, right? I'm not going to challenge you again, right? At least for a time being. Typically, these mechanisms have a timeout, right? Where if there's no conversation, no interaction between the client and the server, for a particular threshold, then the server will assume that the person has gone away, right? That that they didn't log out, they didn't explicitly log out, they didn't explicitly tell the server that they no longer want to maintain this conversation. But we can time them out, right? And we can throw away the session, right? So that next time around they're gonna be challenged again, right? To identify themselves, right? And this is important, right? Because these session objects, these are instances of data structures that the server have to maintain, in their memory space, right? So memory space is limited, right? There's only so much memory space that the server has, right? So it is challenging in the fact that you have an infrastructure that has to maintain some information about dozens, hundreds, thousands, tens of thousands of people, right, in one single memory space, or in a cache, or on a fast SD card, or something where I can quickly retrieve it from the CPU, right? And so ideally we want to make that memory space as small as possible, right? So that we can serve as many people at once simultaneously. Okay. But with that in mind, let's run through a couple of examples here of what it would look like. Right. So for instance, here Alice comes in, right, and she uses the browser to navigate to, say, acme.com, right? And this is Alice's first time going to acme.com, and the browser, if the browser is configured to support the cookies infrastructure or the cookies protocol, right? What the browser will do is that it will check to see in its internal file system, right, a data structure that it maintains in a file, that we're going to call the cookie jar. Is going to check to see, hey, do I have a unique identifier, a cookie, right, tied to the acme.com domain, right? And so typically in this cookie jar or in this cookie store, right, it's a data structure that it's a hash table that has a, the key is the domain and the value is the cookie. The cookie could be any string, right? It could be usually not very big, 256 characters. It could be uh, bigger, right? But typically it's fairly short. It's some unique identifier, but it could be any string really. So you have this map of domain string, domain string, domain string. So it checks to see, okay, do I have for that particular domain, do I have this cookie, right? And the browser has agreed that if it does have a cookie, it would now take that cookie and then send it back to the server, right? In the header, encoded in the header of the request. Now, this first time around, because the browser has never been to acme.com, there is no cookie in the cookie jar, right? And so the request goes out to the server, right, without the cookie, right? And the server says, oh, there's no cookie. So what the server interprets is that, well, it must be that this is your first time here, right? Or maybe you cleared your cookie cache. You threw away all your cookies. So there's no identifiable information for you. I don't know who you are. So I'm going to create a new identifier, a new string, right? And I'll give it a name. Cookies have a name and a value, name, value, name, value. And it sends back this cookie in the header, in the response. Okay. Now, at the same time, it creates an instance of a session object in memory, right? And it keeps track, a map of saying, okay, well, this cookie maps to this data structure, right? So it maintains some kind of hash table that says, okay, well, for this cookie, there's this session object, right? This instance object, right? Now, the object itself is a hash table. So it's a hash table within a hash table, right? So this session object is a hash table that you can put, you can get, right? You can store anything you want in there by key, right? But itself, right, is inside of a hash table that is mapped by the cookie ID. Okay. So anyway, so it responds to the browser response with the cookie, right? And if the browser has agreed to participate in this protocol, right, it will now make an entry in the hash table in its local file system that now acme.com has this particular cookie, right? Now, next time around, as Alice navigates throughout other parts of the same website, right? And she goes to a different a different page in acme.com. This time around, she does have a cookie, right? The browser checks to see the cookie jar to see if there's any cookies. There is, right? It'll retrieve this cookie from the cookie store, right? And then sends it to the server in the header, right? Now, this time around, the server says, okay, you do have a cookie this time around. It says, and it verifies that it had created that cookie, that the cookie has not timed out, right? What it does is that for every request, right, for every cookie, it maintains a, last time that the cookie was was used, right? So the hash table that maintains the cookies on the server, right, it maintains a, time to live, right? When was the last time that this cookie, it creates also an expiration date, right? It says, okay, this will expire, after so long, right? It also maintains a timer on the session object, right? So it maintains two informations, right? One is whether the cookie will expire and I will just not accept that cookie anymore, right? Now, some servers can be configured in the application layer, right, that to never expire cookies, right? That, for instance, Google does that, right? So that, or they put an expiry date that's way into the future, and that means that you almost never have to log into any of Google's uh, websites, right? You go in there and unless you clear out the cache or you're in a different machine or whatnot, right? The browser will remember you, right? And as you go, from one application to the next, it uses the same cookie and it knows it's you. So it maintains that date, right? Now, oftentimes we discourage folks from doing that. It's a good idea to, from time to time, right, create cookies that will expire, right, and so that, to force people to, make sure that they're not hijacked or whatnot, right? That somebody's not stealing your identity. Now, the second thing that it maintains a timer on is on the session, right? So every time the cookie is used, right, the session, there's a clock that goes on the session that if the cookie is used, we reset the clock, right? And say, okay, well, this was the last time that the session was used. If that time is beyond 30 minutes or an hour, right, or whatever the configuration is, right, the session object is cleared out, right? We don't retain it, although we can extend that. Oftentimes, what Amazon or some online shopping will do is that they won't maintain it in memory, the session, but they'll maintain it as a data structure stored in some database, right? Where it's you again. I have this cookie. Ooh, let me get your session information. I'll go into the database, fetch your session, right, and reinstantiate the session in memory, right? So that we want to give you a seamless uh, you know uh, we want to give you a seamless behavior, right? That you feel that you like you never left the application, that like you're always there, right? We always know who you are, and we immediately give you access to the application, almost as if you had the application running on your local machine, right? That is the behavior of a local application that runs on your laptop, right? The application is for you. You're the only one using this application, and so web applications have been trying to provide that kind of behavior, right? They want to be very, very near what the experience that you would have from a local application, right? That you would install locally in your machine, right? They want to blur that behavior. So anyway, so this session object, right, is retrieved, with the key of the cookie, and then passed on. This instance is passed to your application, right, so that your application can do with it whatever you want, right? It's whatever you want to use the session for, right? That's per application. Each application uses a session however they want, right? But typically, what they would put in there is the current user, login information, identity information, right? Not much more than that. Although you could put lots of stuff in there, right? So we'll see an example here. We could put maybe a shopping cart, like a whole array or something, right? Of items in my shopping cart. Okay, and and again, when the request comes in, the timer on the session object gets reset. Your application can store information into the session using set, right? You treat it as a hash table. You say set keyword, right, or a key, and then whatever data structure you want to store in there, right? We're going to be storing just a simple object that has identifiable information, like the current user. We'll store in there so that each session, Alice is logged in, Bob is logged in, Dan is logged in simultaneously. Each one has a different current user object, right? Alice has her username in the current user. Bob has his current user instance in the session with username Bob, right, and so on. And then that's when we log in and we register. If we come back with a profile in the profile screen, we can read the profile, right, the current user, right, and use that user information, right, to populate the current user on the client. Okay. Yeah, here's another example of Alice retrieving that information. First she is sending some information in the session, and another one here is retrieving that data from the session. Okay. All right, so let's demonstrate this, right? Now, out of the box, Node.js has no support for sessions, right? It doesn't understand what a cookie is or anything like that, right? All those cookies are going to be living in the header, right, of the request and response, going back and forth between the client and the server. So to be able to support this, we're going to install a library, right, that has support for the session. Right? So we're going to install Express Session. Right, so let's demonstrate this. Let's see. Here we have the Node server. And so what we're going to do is we're going to npm install Express Session. Okay. And that should make a new entry into the package JSON. There it is. So Express Session has been installed. Right. We're also going to install some type some type definitions, right, for this library so that it's compatible with TypeScript, right? Since we are using, ES6, right, import, things like that, that are the more modern syntax. So let's do that. Let's import. Actually, no, we're not using TypeScript on the server side. No, on the server, we're not using TypeScript. Okay, so let's demonstrate, right? Let's expand our server. Our current server is pretty simple, right? It's it's installing here in index.js, right? Let's start it. Nodemon index. But yeah, so we have we're using the Express library, right, where that has some of the lab exercises that we've been playing around with, right, and so to use the Express session, that library that we've installed, right, we would import it from the Express session, right, and then we would configure it, right, as follows, right? We create a session options object, right, and we would configure a secret string, right? That what this is used for is that we can sign the cookie when we create these cookie strings. We want to make sure, right, that the server knows that it has created these cookies, that these cookies cannot be tampered with, right? We want to make sure that that if anyone is listening for for these requests and responses going back, for the client and the server, that if somebody's stealing these cookies, right, that only the client and server, right, are going to be able to establish this communication, right? So the cookie itself is encrypted, right? So only the intended user, right, the intended client, the intended browser will be able to use this cookie, right? If somebody intercepts this cookie, it'll be useless to them, right? Even if somebody intercepts it. Now, typically we sign it using this string. It's a hash on it. Now, it's a bad idea to hard code these strings as part of the source code. So more commonly, what we do is that we store this in an environment variable, right, in a file, outside of the server code, right? And that's in our case, right, we're going to store it in an env file like this, right? In this env file, right, we're going to create an environment variable that we can load here dynamically, right? And then we can use it to sign the cookie, right? Also, the cookie mechanism works differently locally in your machine as opposed to when it runs on Heroku or render.com or some other service, right, that hosts your server, right, your HTTP server. And so we have to have logic that behaves differently with the sessions. In particular, one of the big differences is that locally, the information that's going back and forth between the client and the server, it's not being encrypted, right? And we are using just plain old HTTP between our React.js client application and our server. But when this is going to be running remotely, right, we know that Netlify is going to be using HTTPS, right? And so is going to be render.com, right? And because it's going to be using HTTPS, right, cookies are going to have to be supported using the HTTPS secure protocol, right? So we have to write logic that, in addition, right, if we're not running on the local development environment, then we need to do a couple other things, right? We need to turn on, the fact that typically in a remote environment, the browser doesn't get to talk directly to the server. In between, there's an intermediate server, right? That usually is Nginx or is a load balancing machine, right? That decides who to send your request to, right? Because it's not just you talking to the server, it's thousands, tens of thousands, hundreds of thousands of users, right? So usually there's a load balancer, in between the browser and the actual server, that goes out and distributes the request out to multiple servers. So we have to turn on proxy true. We also have to turn on secure. Secure, configures the communication to be as secure using the SSL, HTTPS secure socket layer, right? And so that all the communication is encrypted. And for encryption to work, another thing that we need to configure is that, right, you need to know what the domain that you're running on, right? That the where the request was intended for, right? So that if there's any other IP address in between listening for this, all that communication will be for naught, right? So we need to know that, hey, if the communication comes to us, then yes, right, the communication was intended for us and no one else, right? So anyway, so these are configurations that are only valid, right, for when we are running remotely on a server, right, not locally. Locally, we don't want any of this, right, because we don't have HTTPS, we don't have a load balancer in between, right? We just have the browser talking directly to our local Node.js server. Okay, so this is the only configuration that we want. Now, once we have that, we turn on the session, right? We instantiate the session. Now, notice that we're using app.use. Remember that we had discussed that what app.use does is that we are configuring that all requests that come in, not only GET requests or put or post or delete, right? All requests that come in, right, are going to pass through here, right? They're going to be intercepted by whatever route. So this is a route, right? So the session declares a route that consumes or intercepts all incoming communication, right? And what it does is that it uses the options, it configures that route, and what it does is says, okay, well, I'm going to look at the header, right? What this route does is that it only cares about the header, the cookie header, right? No other header. I don't care about any. So it knows how to read the header, right to the cookie header, right? And what it does is that it parses out these cookies. It also is responsible for instantiating, right, these session objects, right, and mapping it to the cookie identifier. So this session library, the session library here that we are using here, the Express session that we just installed, right, it's going to intercept all incoming traffic, right? It's going to parse out the cookies. If not, it's going to create new cookies, right? And so it's going to, for us, it's going to maintain a map of all the cookies that it generates and all the HTTP session instances per cookie, right? And what it's going to do is that it's going to make all that information, all that session information available in the incoming requests, right? So this is a pass-through. It's a pass-through route, right? That it doesn't end there. Notice that all our routes are going to live afterwards, right? So all these intercept all that, and then it passes the request on to the next router. Right? So these are all routers that are strung together, right? The first router, right, that we discussed last lecture was the course router. Remember that? Right? If you remember, there we had run into an issue where the browser was trying to send requests over to the server, and we got a course exception, right? And the course exception we had discussed that there's some limitations on browsers talking to servers, right? Originally, browsers were only allowed to talk to the server from where the code that JavaScript was downloaded from, right? In our case, it's on port 15 something or whatever, right? But it was talking to this server that was running on port 4000. So that was a no-no, right? So course is also, right, another route, right, that what it does is that it configures that communication and it says, well, you can configure whether I should allow it or not, right? So course, last lecture we had configured so that it would allow all communication to come through. Now, because we are now going to implement login and sign in, registration, profile, and people are going to be authenticating themselves, Now we need to be a little more careful, right, where the communication is coming from, right? We shouldn't allow just anybody talking to us, right? Only folks that have identified themselves, right, maybe established an HTTP session with us, right, and we have some kind of authenticity. So because we want to support cookies, for instance, right, where the cookie, we're going to use these tokens, right, to know who you are, we have to turn on the fact that course is going to know or going to accept only information, only logins from certain locations, from certain domains only, right? If the login comes from anyone else that we don't know about, right, and it's posting or putting or information to us that we don't know about, we don't want to know, right? So we're going to also configure origin, saying we're only going to accept communication from this incoming a browser or from wherever this is running from, right? We're going to accept requests only from this IP address or this domain, right? So locally, my browser, right, is running in localhost 5170. That's my local host. But remotely, right, my browser is going to be running on netlify.com or something, right? So we are, when we deploy this on Netlify, we're gonna have to say, okay, well, we're gonna say, well, my Netlify domain is running over there, right? I want to accept incoming requests from my Netlify domain, so I'm gonna whitelist it over here. I'm gonna say it's okay if my Netlify application comes and talks to me and identifies themselves and whatnot, right? So please establish a trust with the course, and also they're going to provide their identity through the use of cookies, right? So that's our new configuration for course. And again, notice that it's using app.use. That means that, again, this is all requests that come in are going to go through this router, right? And it's a pass-through. It's going to then let the request continue onto the next route, right? And so we have two routes here, right? One is that handles the course. Then after that, we have another route that handles the session, right? So after the course allows the request to come in as a cookie, it comes from this particular domain. All right, the session gets it, right? And says, okay, well, all right, I'm going to parse out the cookie headers and whatnot. I'm going to create the sessions, blah, 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 right? And then I'm going to let the request to continue, right? And then we get to another route over here, which is express that session. So express that session, right? We discussed this in our previous lecture, right? Is what we needed for being able to parse the body, right? That might contain JSON information, right? That encoded data, formatted in JSON, right? So JavaScript object notation, right? So this is a route, right, that tries to parse the content in the body, in the incoming request HTTP body, right? If it found JSON, it would parse it, would make it available in the request.body object, right? Now, these three routes need to be declared in this specific order, right? First we need to do the course, then session, and finally express in that order, right? Otherwise, this won't work. And finally, after we've done those three app.use, then we have our custom routes, right, that handle labs and hello, or today we're going to be doing Kanbas and logging in, right, and whatnot. Okay, make sense? All right. Okay, so now that we have the session configured, right, let's practice, right, the using of sessions. Right, we'll do some really trivial examples, right, on how to use the session, right, and then we'll we'll use just a plain browser to demonstrate the behavior, and then we'll, once we've understood the behavior, we can then start building on that, right? And we'll build some interesting sign-in screens and profiles and whatnot from the Kanbas application, right? So yeah, so let's create a controller, right? A session controller, right? That is going to give us a chance to practice a session, right? Okay, so here I'll put it in the labs. So we'll create a session controller, I call it. session controller.js, right? And so this is going to be a function, export default function session controller. Okay. And then from the index, we're going to import the session controller. So import session controller, right? And we're going to pass app to it. There we go. So in here, what we're going to do is that we want to demonstrate that we can store that from the application side, we can store information that is specific to one browser, and then we can have another browser have a different information for the same communication path, right? For the same request, right? One browser is going to have one information, and another browser, Alice using Chrome, she's going to store something in the session, and then Bob using Safari, right, is going to store a different thing, right, into the session information, right? So let's demonstrate that. So let's create this handler here. So there's going to be a function. There's going to be a call set session, where in the request we're going to pass in a name and a value, right, encoded in the params. So there's going to be a URL that's going to receive name and value, and we're going to store in the session. Notice this request at session. That's a new object, right? Session now that didn't exist before, right? It's now in the request. Remember, same thing when we did body, right? Request.body didn't exist, right? The JSON that's stored in the body wasn't there until we added, right, this route over here, right? The express session that parses JSON and now makes it available in the request, all parsed and nice, right? So same thing, session. Session is a new object that is being added to the request object, right, by this route. Right? So this route is intercepting the incoming request, right? It's creating a cookie, it's creating a new instance object, and then it's manipulating that the request, the incoming request. It's adding this session object into the request so that, and then it lets the request continue. So by the time it gets to me, right, now I have the session object there. And what is the session object instance? It's a hash table, right? So it allows me to, right, add stuff. It's a map, right? It's a map data structure that has keywords and values, keyword value, right? And so the keyword is a string. And so what we're going to do is that we're going to pass the keyword, right, map into the data structure, and we're going to pass a value. Now our value is going to be a string, but we could put anything in there, right, into the hash table. Here's going to be a string I'm going to put in there. And then finally, I'm going to respond with the entire session object so that we can see, what is inside of that object, okay? And so I'm going to now map this to a URL. There it is. So it's going to be into get. So this is going to be a get that says in the API, /API session, then set. And then I'm going to pass in as parameters encoded in the URL, the keyword and then the value that I want to put into the session object, which I'm going to parse from the parameter here. I'm going to parse the value, and then I'm going to use it to store this information into the session. Make sense? Right. So not only do I want to be able to retrieve information, I want to be able to, not only do I want to store information into this session object, but I want to retrieve it, right? Remember that this session object is different from Alice or Bob. If Alice comes in, right, Alice will have a different cookie than Bob. Bob will have a different cookie value. So our interceptor here is going to say, oh, Alice has cookie 1, 2, 3. So let me go fetch, the session for 1, 2, 3 for that cookie, and it's going to make it available here. Request that session will be the object for cookie 1, 2, 3. Now, if Bob comes in, the request comes in here, says, oh, I see the cookie is 2, 3, 4, right? So it's going to retrieve the object HTTP session for cookie 2, 3, 4. That means that when it gets to here for Bob, this instance of a request.session will be a different instance completely, okay, for cookie 234 for Bob, okay? That means that whatever information that Alice might have put in here, right, with, value name for Alice, even if Bob uses the same name and the same value, right, these will be stored in different session objects, right? They'll be completely different, right? Two different separate. They don't, interconnect, right? So yeah, not only do we want to write to the session, we want to be able to retrieve from the session. So let's do that. So I want to be able to retrieve from the session. There it is, right? So in the get session, yeah, and that's a good, yeah, that's a great, yeah, my AI knows me very well. So, yeah, so for get session, right, we're going to, the API session get, right, we provide the key, and what we expect back is whatever was stored at that key, right? So we're going to parse, right, that key from the URL, and then we're going to use it as an entry into the map of the session to retrieve the data, right? And then we're going to just send back the value of whatever we had stored in there, okay? Right. And finally, what we're going to do is we want to be able to destroy or reset, right? Throw away our session. Maybe if we log out, right? We want to end the session prematurely, right? And just have it forget anything information about me, right? Which we don't need to. That's going to happen anyway, right? After a timeout, right, of 30 minutes or to an hour, the sessions will be cleared, right? It's not going to remember anything. So let's but nevertheless, right, we can do that programmatically, right? We can retrieve all elements in the session, all items in the session, or we can reset it. So we can say, request session dot destroy throws out my session, right? Not all the sessions for my cookie, right? So Alice, if she wants to log out, right, she would send a request to this, right? Would destroy her session object, for cookie 1 to 3, but all the other cookies, all the other sessions, right, are still valid, as long as they haven't timed out. Right? So let's create APIs for this. So reset and get to get all of them. All right. Okay. Actually, I think this was, I prefer this, just session, retrieve all of them. All right. Yeah. So let's try it out. The server is up and running, so I guess we could try it out right away. Let's see, we can go to localhost 4000. Right, we have the welcome to homepage, and so let's try it out. So let's see. Say I'm Alice, right, and I want to do API session, and I want to set in my cart, right, I want to set set cart and then the value of stuff that I want to put in there, right? I want to have a notebook, right, and a pencil, right, and a calculator, right? So that's what I put in my shopping cart: notebook, pencil, and calculator, right? So I do that, and the server responds with the whole session object and says, okay, well, it's a map, right? We have 2 entries into the map, cookie and cart. Cart is the entry point, and then I've just stored a string in there. Okay, so I can set it. I can also retrieve it. I can say, localhost 4000, API session, and I can get, right, the cart. Right, and notice that it retrieves the information that was there. Right. Notice if I use any other key, right, there's nothing there. It just returns null or crashes. Let's see. Okay, it's still there. Now, what about, so this is Alice, right? And she can manipulate the card, she can add to it or change it or whatever. But, what about Bob? Right? So if I go to Bob and he goes to the same URL localhost 4000 API session, and I want to set cart. I want to put a pen, yeah, a book, right, an abacus. Okay, so there it is. So it says that he added to the cart a pen, a book, and an abacus, and he can retrieve the cart. You can say, I want to get the cart. Right? Notice that he comes back with pen, book, and abacus. Right? So notice that both URLs are exactly the same. See that localhost 4000 API session get cart is the same exact URL as API session get cart. See that? And the reason the responses is different is that we are storing information for the session for both places. Now, the way you see this, the mechanism down behind the scenes is that if you inspect the communication, right, and you look at the network, what's happening when you retrieve this information, if you look at the cart, right, you look at the headers, right, you'll notice that they're notice that there is a header called cookie in here, right? That was not there before, right? Um, and if I and notice that what the server has done, right? It has created a cookie called connection.sid, right? Equal, that's the name of the cookie, and then a unique identifier, blah 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 blah, whatever, some long unique identifier, right? If we do the same thing for a Safari, right? And we look at the network communication, maybe the storage, you'll see that there's a cookie here as well, also with connection SID, right? With a different ID, with a different value. So this value of the cookie, right, ends with KFLO, whereas here ends with something else, right, with WM1U, right? So these cookies are different. That means that they are mapped to two different HTTP session objects, and that's how Bob and Alice, have two different information, from the um, from the HTTP data structure. Okay. All right. Yeah. Then certainly you can try out resetting and whatnot. All right. Let's now start using this skill, right, of using sessions and all this, right, but right, to implement some really cool features, right, for the for our Kanbas application. Okay, let's do that. Okay, so let's take a look at adding HTTP server to the Kanbas application. Okay, let's see, where is it? All right, okay, implementing the Kanbas Node.js HTTP server. And so again, right now, right, our React application, right, is using a database, right, that is being hosted on the React application, and we want to be able to move all that, to the server, right? So let's see the current implementation of our React application, right? Right. So currently we have a database, right, where we have been putting all our JSON objects. We have been, you know, collating it into this one index file, right? And then all the screens have been using this database. And so what we want to do is to move this database to the back end, right, to the server. And eventually, where we really want it is put it in the database, right, real database, right, a Mongo DB non-relational database, which will be the topic of next lecture. But for now, we want to learn how is it that we're going to interact with the server, right, to retrieve data, right, that it's no longer going to live in the React side, right, it's going to live on the server side. right? So the way we're going to do that is that, we're going to, just like we did for our React application, right? We're going to create a database, right, on the server side. So let's do that. So in Kanbas, right, in Kanbas database, we're going to create a new folder here on the server side, like that, right? And in there, we're going to create a course, courses.js. Right? So this is going to be our first, file that's going to contain data for us. And we're going to move the courses.json content in here. Right? So let's do that. So on our client, we have courses.json. Right? So let's move this over to the server. So I'm going to copy this, right? And I'm just going to dump it right here. I'm going to put it right here. Right? And now this could have been a JSON file as well. The thing is that, out of the box, Node.js doesn't know how to import JSON files. And so what I'm going to do a shortcut here. Instead, I'm going to work with JavaScript files. I'm just going to do an export, right? Default, just is going to export this content as just JSON, right? So I'm going to do this with all the files, right? So one by one. So we can do courses, we can do modules, right? We can copy this, right, and move over. I'm just going to paste it in here. And I'm just going to rename it with as a JavaScript file, and I'm going to do an export default, right? So once we have each one of these files moved over, we can now import them into a single index file, just like we did in React, right? So let's do that. We can create an index file that is going to import all of them into a single data set, right? So let's do that in here. We can create a new index file, which is going to import all these. Now we don't have all of them. We only just have a few. So let's see. We do have we have courses, we have modules. We don't have assignments. We don't have. So let's move those. Let's do those a little later. Grades, enrollments. Actually, maybe I do want enrollments. Let's do enrollments. We can do grades and assignments a little later. So grades I'll do later, and assignments we'll do later. Right, but let's bring enrollment users and enrollments. So let's do that. So here are enrollments, here are users. I'm going to copy that and bring them over to the server. There we go. Let's rename these to be JavaScript files. Right, and we're going to do some export default for both, only because I'm lazy. Export default. Okay, so index should now have those 4 files collated into a single index file. Okay, so now that we have the database on the server, right, let's create APIs that allow us to retrieve all that, right? Now let's focus first on the account screens, right? So for currently the account screens, right, have a couple of screens that allow you to sign in, right? And but right now they're using users that are in the database in the React application. We want to use the database on the server instead, right? So we need to expose all that data that we have created, we have moved over to the server. Now we need to rethink, right, how is it that this React front end application can use the remote server where the data now lives, right, instead of using the local data structure, right? So let's take a look at doing that, right? So first, let's start the React application over here. Here, run dev, and let's bring it up. And there it is. So we have a sign in, right, that we can do Ada 1, 2, 3. We can sign in, right, and it navigates here. It displays the courses. So we were going to be able to do that, but from the server. right? And also we have a refresh. It clears out the fact that it doesn't remember that we're logged in. Right? So we want to be able to save that. We want to be able to fix that, right? We want to be able to maintain the fact that we are logged in and it not forget that we're logged in. And the server's not going to forget because the server has, it can remember things because it's storing it in its memory. Now in the browser, if we've refreshed the browser, right, we lose that information. But because the server is going to remember that we are logged in because it maintains sessions, right? We can always go back to the server and retrieve that session information, right? We're going to make the server the single source of truth, right? As opposed to have the client maintain session and maintain state and all that, right? The single source of truth is going to be the server now, right? And eventually the database, right? But for now, let's learn how is that we can integrate with the server. Next lecture, we'll talk about how we can extend that with a database. Okay. Okay. So let's see. So what we'll do is that we're going to create what are called data access objects. So data access object is a design pattern, right, in software engineering that is very common when you are dealing with some kind of data source, right? In particular, we're going to be wanting to use that to talk to a database, right? And what it does is that it encapsulates all the operations of talking to a low-level data source, right? And encapsulate it in a high-level interface, right? That is more useful for the rest of the application. So it hides, right, the idiosyncrasies of talking to the data source, right? And it makes a nice little API, right? So that the rest of the application doesn't have to know anything about the actual data source. And this is going to be nice because for us, our first implementation is going to be that our data source is this database, right? It's just a big object. But in the next iteration of this, right, the DAO will be talking to an actual database. Now, the nice thing about the DAO is that it hides this fact from the rest of the application because the API is going to be the same, right? It's still going to be the same functions, the same parameters. So the rest of the application doesn't have to know, right, that at some point the data source is just arrays and objects. And then in a different iteration, the implementation is a non-relational database, right? And then maybe down the line, we might implement this with a relational database, right? Or whatnot, right? So the rest of the application doesn't have to know. So that's the point, right, of using a DAO, right? So let's create under users DAO, because we want to implement all the screens that deal with the user identifying themselves, registering their profile, knowing who they are, logging in, right? So all that we're going to encapsulate in users DAO, right? So let's create that file on the server. Right, here's a users DAO. And in there, let's declare several CRUD operations, right? And let's talk about it. Yeah. Okay, so here are all sorts of things that you might want to operate on users, right? And you might want to create a new user or retrieve all the users or retrieve the user by their primary key or retrieve them by their username, especially if you're registering as a new user. I want to check to see if the username already exists, for instance, right? Or I want to identify this person by their credentials, right? If they provide their username and password. I want to update them, right? If they change their their address, right? Or they changed their account information or whatever, I want to be able to update them, right? I want to be able to remove the user. Perhaps, this is a rowdy user, right? I want to kick out them from the social network, right? So the system administrator wants to delete the account, right? So these are all sorts of CRUD, operations that I want to be able to manipulate the user's data structure. Okay. Now, right now it's implemented based on the database index, right, which does have a user in there, users. But in the next implementation, we're going to replace this we're going to replace this with an actual database, right? It's no longer we're going to go out to the database, right? Also here we have a UUID library that we probably need to install. I don't know, do I have that installed? Let me see, in the package JSON, in the package, in our dependencies. Okay, I do not have the library installed, so let me install that. So npm install UUID. There it is. So there's a new dependency there. Perfect, that's the library. I'm going to use that for creating unique identifiers. Okay. Okay. So we have the beginnings of a DAO. Let me restart this. Maybe there are a few things that are not implemented. No, I think these are all implemented. Okay, very good. Then we want to integrate this to a, so that the user interface can talk to this, all this CRUD operations, right? So to integrate, we need to expose all this, all these operations. We need to make them available to the user interface. And to do that, we're going to create a route, right? Routes that the front end React.js, right, is going to be able to interact with, by posting or getting or deleting or putting, right, from the React application. So let's create the routes, right, for the user. So here are the routes. And so now these are all not implemented. None of them are implemented. And so they're all going to be implemented in separate functions, right? And they are all, right, wrapped up into these, HTTP get and post and put and delete, right? That is going to invoke each one of the functions. So for instance, to create a new user, we're going to post to /API/users, right? If we want to retrieve all the users, we're going to do a get, right? API users, find all users, right? Now, obviously, we have a lot of these already implemented in DAO. We're going to import to DAO, right? And we're just going to rewrite these functions in terms of those CRUD operations implemented in the DAO, right? And then we have put to update, delete to delete. Now you'll notice that there is a running theme here. There's a pattern if you've identified it, right? Notice that for creating new users, we're using post. See that? To read or retrieve users, like find all users or find users by ID, we're using get, HTTP get, right? For updating, we're using HTTP put, and for deleting or removing users, we're using HTTP delete, right? Now this is by design, right? We are following a convention called the REST convention or RESTful. We're creating web APIs that adhere to the RESTful set of conventions, right? And which states that for creating data, we should use post, for retrieving get, for updating put, and for removing delete, right? So that's part of the convention. Another part of the convention says that you should, in the URLs, should follow a pattern, right? In this pattern, you should only find nouns and primary keys. That's it. Only nouns and primary keys, okay? Which we have, right? So notice the noun that we've chosen is users. Also, the convention says that the nouns should be plural, right? Very much like the conventions that we follow when we're creating tables, right? In a relational database, typically we use lowercase nouns, plural nouns, right? Also, typically we use underscore for the names of tables to if you have a compound word, right? We use a underscore under that. What else? Well, for instance, in Java or C#, right? The names of classes are typically capitalized. Typically, they are nouns and they're singular nouns, right? So each infrastructure has its own set of naming conventions, right? So the RESTful naming conventions, we're going to be using plural nouns, all lowercase. Okay. Also, as part of the convention is that if you provide a unique identifier, right, as part of the path, right? That should be interpreted as, wanting to retrieve or manipulate, right, a particular instance in the data set, right? So for instance, here, users and then followed by unique identifier, right? That should be interpreted as in, I want to do something with this unique user that is identified by this primary key, right? The get should be interpreted as I want to retrieve that specific user. Put should be interpreted with the user ID, means that I want to update or modify that specific users, and a user ID in a delete, right, would be interpreted as I want to remove that particular instance of a user, right? Now, if you do not provide the primary key, then the interpretation is that you want to manipulate the entire data set, right? So for instance, the post and with the users that doesn't have an ID here is interpreted as in, I want to append or create a new instance, right? And I want to add it to the current array or collection of users. Get without a primary key should be interpreted as in, I want to retrieve all the instances of all the users, right, from that collection, right? So yeah, anyway, so these are all naming conventions. Notice that they all start with API. That's also part of the convention where we want to distinguish these URLs, right, that are meant to manipulate data, right, or access data, delete data, CRUD data, as opposed to URLs that are meant for visual, right? Where you want to display some content that is mapped to some URL. So notice this is a URL. We're not getting any data. We're getting some visual representation of this. So we want to distinguish URLs as being consumed by humans, or URLs that are being consumed by some software, some process, right? So, and these specific URLs are not meant to be used by humans. And so nobody's actually going to type, HTTP/API/users. Well, I am, because I am a developer. But in general, users are not going to be typing these URLs to view any screens. Instead, they're going to be used for interacting with other processes. In our case, it's going to be integrated to the React application, so it can talk to this other application, right? Now, to distinguish these, we typically precede, right, or prepend a key or some unique identifier that gives meaning to us, saying, hey, this is meant for implementing an API or a data set or whatever. So some of the common keywords are API or data or REST, right? I'm using API, right, to make it clear that this is an API, right, not meant to be consumed by humans. Okay. Now I have a few other endpoints here for being able to identify yourself, register, right? Being able to sign out or retrieve your current profile, right? Implemented with these 4 functions: sign in, sign up, sign out, and profile. Okay. Now notice that these are all posts. Okay. And this might seem like we're breaking the RESTful naming convention. Notice that here we have verbs. Okay, these are verbs, so it's kind of, yeah, we're breaking up a little bit the RESTful API. Now the reason I'm doing this is that because this is more for this data to these APIs are for establishing authenticity, identity. These are not for day-to-day creation and update and retrieval of legitimate data, right? This is just identifying, establishing trust, right, between the 2 applications before they even start talking to one another, right? So this is a little bit outside of the common access of data, right? This is establishing authority, right? And also, I'm using post because post can be encrypted, right? HTTPS can encrypt this information. Typically they're going to be sending back and forth information that is credentials, right? It's sensitive information, right? So we want to be able to encrypt this information, and so using get would not allow me to encrypt this data going back and forth, whereas post would allow me to do that. Also, post would allow me to send information as part of the body that can be encrypted, as opposed to you cannot encrypt the URL, right? In the HTTP request, right? So that's why here these four operations seem to break the RESTful convention. It's because these are very special URLs that are not meant for day-to-day data transfer. Okay. So let's implement each one of these requests, right, to to be able to implement the user API. Okay. Okay, so we have the routes. Let's import the route in our server. So in our index of our server, let's import our brand new user routes, and let's pass it an instance of the app. Perfect. Let me close that. And let's implement first the sign in, sign up, and profile, right? So that we can implement those screens, right? So that they can identify and maintain sessions and whatnot, right? What we want to be able to demonstrate is that we can have two people logged in at the same time, one maybe with Safari, another one with Chrome, another one with Firefox, right? Everybody logged in and everybody looking at their particular information, right? So let's implement sign-in first, and sign-in is just going to be the lookup, right, of a user by their credentials, right? So let's implement sign-in. So here's sign-in, the body. I guess I have the whole function. Let's see, the whole function. There we go. So we're going to pass in the body, we're going to pass in the credentials, username and password. We're going to extract that from the body. We're going to use the DAL. We need to import the DAL. Okay, we have it imported already. We use find user by credential, which is going to just iterate over the array of users, looking to see if there's someone who has those username and password. It's going to return the instance of the user that matches. Okay. And then what we're going to do with the current user, we're going to just send it back to the client. Okay, that's it. So nothing fancy yet. In the now on the server, on the client side, let's create an endpoint, right? A client application on the React application, so that we can post, right, to our server, right? So let's create on the account client, right? On our React side account, we're going to create a client here, right? That is going to use Axios, right, to post, right, the credentials. So credentials is going to include username and password. I'm going to post it to the remote server, right, API users, the sign-in. So this is being mapped to this right here, this sign-in right there. So that right there, users API users sign-in is mapped to this. See that? API users sign-in. So from here, I'm going to pass in the credential. I'm going to post them. I'm going to extract it from the body. So any username and password that I pass in through here, right, I'm going to parse it from the server. So I'm going to look them up, and it's going to return the current user. That's going to come back in the response. And so my data is now going to include the user that I found in the array. Okay. So now the sign-in screen, we can refactor it so that when I click on the sign-in button, instead of using the local database, it's going to use the client that's going to go out to the server, right? The current implementation, right, of my sign-in screen. In my sign-in screen right now, what it does is that, what does it do, right? Notice that it uses the local database, right, to look up the user from the local database. We don't want to do that anymore. Instead, we want to go out to the server and do this, right? So let's rewrite this so that that happens. Okay, so we can import the client that we just wrote, and this is going to replace our database, right? We're no longer going to use the database. We're going to contact the database. So now our db.users.find is not going to happen in the React application. It's going to happen on the server. The server is going to do the users.find, right? Not us here in the browser application, right? So we're going to convert our sign-in function to be asynchronous now because it's going to go out to the server. Our communication needs to be asynchronous. We practiced this in our lecture last lecture, right? And the user is going to come back not from our iterating, looking in our local database, but from client.signin is going to send those credentials, user and password. Now this user hopefully comes from the server, not from our local database anymore. Okay. Let's see. Okay, so let's try it out. Let's see if this blew up. We can see the communication now. Let's see, we can say network and check to see if indeed it's going out to the server. So we can say here, Ada, 1, 2, 3, we're going to sign in. Okay, let's see, the server did respond. Hopefully, there we go, right? The server responded. All right, so notice that this information came from the server. And it's user 777. Here's the request that went out. See that? Post. Right? The localhost API uses sign-in, post. Notice that we sent as a payload the username and password. That's what went out to the server. The server responded with this object, right? And what we did is that if there's a user, then it goes to the Kanbas dashboard. If not, it's going to alert an invalid credentials. Let's try that out. Right? I'm going to go back to my sign-in. I'm going to try some weird stuff, right? So not a actual user, some bogus. So the sign-in, notice that comes back with an invalid credential. Right? Notice because this sign-in, notice that the header went out, the payload was some gibberish, and the preview is nothing, right? And we coded it so that it would pop up an alert. So yeah, it's working. It's going out. It's finding users. So Ada 1, 2, 3 does navigate. Okay, makes sense. The preview comes back. Excellent. All right, so let's now how about the sign up screen. I want to be able to create new users, right? So in our DAO, right, we had already implemented a create user, right? That what we're going to do is that we're going to receive the user that wants to sign up with us, right? And what we need to be able to do is, first check to see if the user already exists, right? If so, we don't want to create them. But if they don't exist, we do want to create them, right? And so we already have implemented in our DAO, right, on the server, in the DAO, we had already implemented create user, which what it does is that it receives an instance of the user, presumably with some identifier, the credentials already, right? The username and password that we want to use already. We're going to create, plus if they want to provide also first name, last name, and all the stuff, that we're going to accept as well. And we're going to create a new unique identifier, and we're just going to append it to the array, right, at the end. Okay. Also, we have a find user by username. We're going to check to see if the user already exists. If so, we don't want to create them again. If not, then yes, go ahead and create them, right? So that's going to be our implementation for our route. So this sign up, right, we're going to need all that logic in here, right? So let's I already have it implemented over here. There it is, right? So we're going to do sign up. Let's sign up. Yeah, sign up. So I'm going to paste it in here. Let's go over it real quick. So it's going to receive in the body. I'm going to pass in credentials. I want to be Bob at bob.com or whatever, my username and password. It's going to check the username that I pass, right? And try out our find user by user and see if the username is already taken. If the user already exists, I'm going to respond with an error, right? So response.status allows me to respond with 404 or 400 or 200. 200 is okay. Anything above 200, 300 and above, right? That's those. No, 400 and above. Those are all errors. And then I can provide some information about the error. The message is, user already in use, so I can pop up some alert saying, this user is already taken, and I'm going to return. Otherwise, instead, I'm going to keep a local variable of current user, right, so that I can remember that this person is the current user. probably in the sign in, I want to do the same thing. Yeah, so you notice that if the user does already exist, I'm going to remember that the user is this person, right, in the local instance. Now, notice I'm not using session, right, because we don't have, we haven't discussed that just yet, right? I'm going to be maintaining this current user object, but notice it's only one object, one current user object. So if Alice comes in and logs in, Alice is the current user. But if Bob comes in and signs in, right, then Bob is the current user, right? And at no moment do I have a capability of maintaining both of them signed in at the same time, right? So that's where we're going. That's where the session is going to come in a little later. So anyway, but if the username is not taken, I'm going to create the user, right, and and I'm going to respond as this is the current user. Okay. And then I'm going to create in the client. I'm going to create a sign up, right, in the same client that we had just a minute ago. In the client over here, we're going to paste that in. Notice there's also a post sign up, and I'm going to pass in the user object, which is going to be username and password, right, and that's going to be from the sign up screen. Let's see the sign up screen. Did we implement the sign up screen? I forget. Okay, no, we didn't implement the sign up screen, but that's fine. We have it right here. Let's copy from this cheat sheet, and let's look at it in a minute. What we're going to do is that let's import this. What else do we need to import? We don't need React here. So we should be able to navigate there. Let's try it out. So let's account. Okay, I'm already logged in, but if I refresh, it's out. So sign in, sign up. Okay, so sign up is going to be able to sign me up. Let's try it out, see if it works. Let's see if I do Ada123 already exists. Let's see, sign up. Again, it's coming back with a 400, right? The message the username is already taken. But if I do Ada123 and password 123 also, sign up. I am that does work, right? They sign me up. There it is, sign up. It went out. Here's the headers. Options. Okay, now this is the pre-flight, right? This is asking for permission from the server. Is it okay if I sign up? Asking for my options. The server responds with, yeah, sure. You can put, post, delete, get. You can do everything you want. And here's your sign up. The payload is that we're posting the payload of the username and password of Ada123. And the preview responds with, yeah, I did create you with that username and that password because they didn't exist, and here's your unique identifier. Perfect, right? And then it's going out to the profile. I believe we're storing this information in the reducer, right? So the reducer does remember who's currently logged in. Perfect. So yeah, so we have the beginnings of this being integrating with the server. Okay. All right, let's take a short break, right, and then we'll come back. Right, we'll continue integrating the client in the React application, right, with the server that is implementing sign in, sign up, user authentication on the server. Okay, I'll be right back. Don't go anywhere. All right, so let's keep going. All right, so yeah, so we want to be able to integrate, right, the API that manages the user sign in and sign up and all that, right? Integrated with the front end, right? And for that, we have created an HTTP client, right, on the React side that is able to post, put, delete, right, requests that go out to the server, right? So let's keep implementing several other CRUD operations, right? That we want to be able to invoke from the client, right? So that the server can then manipulate the data structures, right, on the remotely. But that for now is just arrays inside of a database, right? So for instance, once we navigate to the profile, because we've logged in, this information we would like to maybe update it, right? Change and modify. For instance, I'd like to be able to, because we've just created this user, we only have the username and password. We don't have a first and last name. I'd like to be able to set it. Okay, so let's do that. So for instance, on the server side, right, we want to be able to update the user, right? So let's implement it in the update here. Here's update in terms of the DAO that we already have implemented. So in the DAO, we already have a DAO update user by its primary key. We have as part of the URL, we have it implemented as a put, where we're going to put the user. We're going to provide the primary key of the user that we want to update. And so we're going to parse out the ID from the parameters. And in the body, we're going to have the modifications of the user, right? A new username, well, maybe not a new username, but a new first name, new last name, right? Email or whatnot. We part of the updates, and then we pass it into the DAO to update by primary key with the updates. And then, once it's been updated, I'm going to retrieve it again from the DAO. Once it's been modified, I want to get and then update the current user. The current user needs to be updated because it has been modified, right? So we want to have the current user always point to the latest version of the current user, right? And then just respond with the current user. Okay. So on the client side, we are also in the we need to be able to send the put request out to the server. Right, so let's do that on the React side. On the client, in the account, right, we're going to send a put request, right, with the ID encoded at the end of the URL and the new user information. Right, we're going to send it as a put, and we're going to do this from the profile. So from the profile, we're going to add we're going to bring in the clients so that we can invoke this new function that we created here in the profile. So we're going to bring in the client, right? And then implement the update function, which is going to send out the put. So there's so there's the update profile that is going to send in, okay, we don't have the editor. Okay, so we don't have all right, so we can't actually edit it because we don't have a local state variable. So profile, profile would be, there it is. Profile would be the state variable, which we're going to import, right? That I'm going to initialize it with the current user that is in the account reducer. And then we can update it, manipulate it, and change it, whatnot, right? And then we're going to have a button that we're going to click, and it's going to send that put request. And we're going to put it, say, at the bottom where you have a couple buttons here. So a button to sign out, and then a button here to send out a profile, to update the profile, update, like that. Okay, let's see what it looks like. There it is, update. Okay, so we made it W100. So we made it all fairly big. And okay, so maybe put this above. There we go. It's a little better. Sign out probably want to be red. We can style it maybe red or something. And so when I click on update, it's going to do what? It's going to make the changes, right? Send out the changes out to the server. This is the updated profile, and then it's going to presumably change it in the reducer. The reducer should extract the current user again and then update it locally. So we shouldn't have to even change the set profile. Let's see if it works. Let's see. So first name here. Let's refresh. Let's sign up again, or let's sign in. I think I created Ada 123. 123. And no, oh, because the server restarted, so this so 8.123 doesn't exist anymore. Okay, so it says sign up. Yeah, so the because we started the server again, any changes of having added new users, whatnot, all those get reset, right? And while we're developing, it makes sense, right? Because we're going to restart the server several times, right? But once we're done doing the implementation, we should not expect the server to be restarting all the time. So it would have, it would remember lots of the modifications that we have made across multiple requests, right? So yeah, so let's sign up, and let's say we have Alice, we have let's like Bob 1 2 3. So sign up. Okay, so we're signed up as Bob, and let's update presumably. So this would be Robert Downey. Right, so we'll do update. So there it is. So a put presumably went out. Right, so header. Notice that it went out like that. We did a put, right, with a payload of the um, bomb. Oh, looks like we did not send the changes. Oh, we didn't make the changes. So, oh, because we didn't update it. All right. So as we type the first name, right? The first name here, we need to modify the state variable, which we didn't. So let's do that. We'll say, on change, set the profile first name, perfect. And let's do it for the last name. There we go. Okay, let's try this again. Let's refresh. Let's sign up. We'll sign up as should we be able to sign in? I think now we should, right? Bob 1 2 3. Okay, and should we be able to go to our dashboard? There we go. So we're signed in. Okay, let's change Bob. So it'll be Bob Marley. Do an update. Let's try it out. Let's see. Okay, this time around we are passing the first name and last name. If we notice that if we go dashboard, right, we go back to profile, it remembers. But notice that if I refresh, we'll lose it, right? But let's sign out, and let's sign up as someone else. Let's see, Charlie, 1 2 3, sign up. Here's Charlie. So Charlie Brown, right? So update. So the update should have worked. There is Charlie, right? And now let's sign out. Let's see if I can sign in again as Bob. So Bob 1 2 3. Okay, if we go to account, notice that Bob Marley, right? Those changes did work, right? They got stored on the server, and when I log in back as Bob, right, it retrieves it from the server. The updates did take effect. Perfect. Oops. All right. Well, how about retrieving a profile from the server? Notice that we do have a problem that if I refresh the screen, notice that I lose the fact that I was signed in, right? And that's because I'm still relying on the local reducer to maintain that state of the current user. But instead, the server is the one who remembers who the current user is, right? If you haven't restarted the server. So we should be able to recreate that state from the server. The server knows that I'm currently logged in, is the fact that I'm not updating the local state, right, on the reducer, right? That I lose the fact that who the current user is, right? So we need to be able to recreate the state, from the server, which is going to be our single source of truth. Okay, the client is only going to be a copy, right? A cached version of whatever the actual state is on the server, right? So yeah, so let's do that. We're going to implement in the route the profile, which is going to just retrieve what the current profile is, right? So profile, right, is just going to respond saying, hey, who the current user is, just as a reading, for reading purposes, right? So I can recreate the state on the client. So on the client, I can retrieve the profile, right? Here, I can retrieve it, which I can then use anywhere I want to recreate the profile. Anywhere I want to go check to see, is anybody logged in? If it is, just update the reducer so that I can know everywhere else in the application. Right, so that so now this can be used to go fetch, right, who the current user is from the server. Now, where should we do that? Should we do that in the profile? I mean, we could, right? In the profile here, what we could do is call the client and recreate the state information over here. But a better solution is to have that globally available, right? That if I refresh the screen anywhere, not only in the profile screen, but if I'm looking at a module, if I'm looking at a course, if I'm inside of an assignment, anywhere in the application, if I refresh the screen, not only if I'm in the profile, right? Anywhere, I like to be able to, before I render anything on the screen, I want to check to see, hey, was anybody logged in? If so, I want to recreate that state, whether they're a student or faculty or whatever, so that whatever logic I have in my current screen or my current component, that might be driven by who currently is logged in, that can be recreated at the top level, and then that could can trickle down through the reducer, all the way down to the screen that I'm in, right? So what we're going to do is that we're going to create a session object or session component, right? That what it's going to do is it's going to be responsible to go first establish on whether somebody's logged in or not, right? If there is, right, then store it in the reducer. Then once I'm certain that I know whether somebody logged in or not, regardless of whether you're logged in or not, I'll make certain of knowing one way or another. Once I know that, then I'll let the rest of the application, render with certainty, right? Of what should I display, right? As a faculty, as a student, because I know who's logged in, or anonymous. I don't know who you are, right? So I'm going to kick you out to the sign-in screen if you're not logged in. But by that time, I'll know for certain if someone knows. And who knows? The server knows, right? So let's create a session component right here in the account, which is going to be responsible for, session there. We're responsible for, right, going out to the server. First thing, right, going out to the server is going to maintain a state variable of knowing whether I know or not, whether there's a session or not. It's pending. I don't know. So pending is true, meaning I don't know yet. My determination is pending. I don't know, right? And so what I'll do is that I'll, on effect, when this component first loads, is that it's going to go out to the server, going to go fetch the profile, right? And if and the profile might return 404, nobody's logged in, or it's null or something, right? If it comes back with an actual user from the server, I'm just going to put it in the dispatch. I'm going to set it in my reducer so that everybody knows who the current user is or not, right? If there is no user, then there'll be an exception. I'll console the error, right? And then by now I'll set the pending to false. I'll say, okay, well, now I know it's not pending anymore. I know exactly who, whether you're logged in or not. And what I'll do is that's going to drive on whether this component renders its children or not, right? If it's still pending, I'm not going to render anything. But once I know for certain, then I'll let the rest of my body render. Uh, I'm going to wrap my whole application around with this session component, right? So that it's going to either allow you to render or not by the time I know whether logged in or not. Okay. Okay. So the reducer has set current, right? And what we're going to do is that we're going to wrap our application with session, okay? Like that, our Kanbas application. So let's see, our Kanbas application, account, index right here, right? So here's our Kanbas application, and we're going to wrap this whole thing with our brand new session. So that means that I will, this works very much like the protected route. The protected route checks, checks to see whether, a particular, predicate, right? And if it's true, it renders. And if it's not, then it doesn't render the content. So same thing with session. So, but the predicate here is whether something's logged in or not, right? Is there a session or not? Okay. And by the time it knows, right, then the rest of the application will know who's currently logged in or not. Okay. Let's see. So that means that if I go here and I refresh, right, by now I know somebody's not logged in, but let's sign up. Did we start the server? I forget. Sign in. So let's see. Do we have still a Bob? Bob 123. Sign in. Okay. So yeah. So I guess I restarted the server. Oh yeah, because of the profile, we added the profile URL, right? So let's sign up again. It's Bob and 123. Sign up. Okay, now here we're in profile. Notice if I refresh, it used to be that it would clear the reducer, right? And that we would no longer be logged in. But if I refresh, notice that I am here, still here, right? Because the session, right, the parent component has gone out and fetched the profile. See that? It did go out to fetch the profile. It came back with a user that Bob is still logged in. It set the reducer, and now the profile can stay here because I'm not logged out, right? The session, the profile still exists, right? But I've recreated that state from the server, right? So that the reducer now can, notify the rest of the application that, hey, Bob is logged in. He's the current user, and all the screens can behave accordingly, right? So now if I go to my dashboard, I don't have any any applications, but say I go to courses, I don't know, um, RS 101 home. Say I'm here, and I refresh. Notice that it no longer kicks me out to the sign-in screen, right? Because I'm no longer losing the fact that I am logged in, right? It used to be that because the reducer was cleared of the current user, right, it would kick me into the sign-in screen because this is a protected route, right? But now the protected route has a current user because I've went out to the server and the server says that I am currently logged in. Make sense? Okay. And finally, we want to be able to sign out, just clear out the fact that we've identified ourselves. So from the server, we're just going to set the current user to null, right? And then respond with a success message. So sign out, and then from the client, we're going to post that sign out from the client over here. Sign out, right? And so from our profile, we do have a sign out in the profile. We have a sign out here, which right now just sets the current user to null, but actually we want to do this on the server, right? So we're going to do an async here, right? And we're going to first call our server to sign out. So we're telling the server, hey, make that current user null, right? So if anybody asks who the profile current user is, well, no, there is none, right? But then locally, I'm going to tell the reducer, hey, just clear out the current user. So now we're in sync. The server says that the current user is null, and locally the current user is null. So we're in sync. So it's we have this new complexity of now that we have to make sure that both worlds, right, the server state and the client state are always in sync, right? So that makes that so much more harder to implement, right? Okay, so now let's discuss how we would support multiple users because currently there's only one user, right? If I log in here as Bob 123 doesn't exist, so let's sign up, and it says Bob 123. I sign up, so I'm logged in as Bob. I refresh. There we go, right? Now, but if I go to Safari, Safari, right, and I try to log in, it says profile. So notice that Safari also knows that Bob is logged in, right? But if I log out and I sign out, and then I log in as, say, Ada, I'm logged in as Ada. There it is, right? But notice what happens in here. If I refresh, those are the current users, also Ada over here. See that? Even though these are two browsers, they're maybe they're half worlds apart, but they're both always looking at the current user on the server, and there's only one of those, right? This won't work, right? We only really have one single current user at a time. So this is very limiting, obviously, right? So instead, what we're going to do is that we're going to support multiple users. So to do that, right, we're going to use the session that we installed earlier. It's already configured. We did the credential true, we install express session, blah, blah, blah. We already configured that. .env, do we install that? I forget. Yeah, we need to install that on the server side. This is so that we can read the environment variable programmatically. Oh, I'm sorry, this is React. I don't want here is on the server, sorry. Let's stop this. Let's install .env. There we go. And restart. Okay. And so we have an environment variables, right? In the node server, we have .env. Yeah, we have a node env's development. We are going to be receiving communications from our local React application, which is running at 5173, I believe, right? Yeah, 5173, perfect. And we are running locally. Our IP address or address is localhost 4000. This is the secret session string that we're using to sign the cookie, right, to make it secure. And at some point, in the next lecture, we're going to discuss how do we connect to a real database. Okay. So then, I believe we have this already in the index. Do we have .env? Okay, there it is. So yeah, we do have it. Okay, so I had done that already. Yeah, we have all this code already. So yeah, so let's change the current implementation that is for a single user, for sign in, sign up, profile, all that is for a single user. Now let's change that so that it's for multiple users simultaneously. So the first thing that we're going to do is that the code that we have for the route currently has this current user as a local variable. So we're going to comment that out, right? We don't want the single user. Instead, right, this current user should be per session, right? So if I log in as Bob Marley and you log in as Alice and someone else logs in as Bob, this current user should be different for all three of us, right? It should not be just one, right? So this should come out from the session. It should be stored into the session and it should be updated from the session, right? So let's do sign up first. So for sign up, what we're going to do is that, right, we're going to declare this as a local constant, right? So it's not a global let constant. And then we're going to store this user in the session. We're going to say request that session, right? Current user, we're going to store it in there, right? So that when you're asking for the profile, we can look up that person from that session, right? Again, this is different. If I come in and sign up as Bob and you come in and sign up as Alice, right? These will be different session objects, right? So this is a map, two different maps. Alice will have their map, right? And Bob will have his map, okay? And so let's update all these. Same thing for the sign in, right? Also again, right? This is going to be a local constant. Okay, and let's add let's add support for the session. We're going to do, if there is a current user, right, then we're going to store it in the session, right? So we're going to say, okay, store that in the session, and then we can respond. If there isn't, right, we're going to respond with an error saying, nope, this user doesn't exist, right? Sorry, I wasn't able to log you in. But if there is, I'm going to store it in the session, right? And then I'm going to respond with that user, right? For the profile, same thing, right? Instead of using this local constant variable that doesn't exist anymore, right? I'm going to retrieve it from the current session, right? Retrieve from the current session and do some error messaging, right? If it doesn't exist, I'm just going to respond with a 4.1, right? Just a security, it's a security breach. If it's a user, I'm going to respond with 4.1 and return. Otherwise, I'll return the user from the session. And finally, when we sign out, we're just going to destroy the session, right? Instead of null, right? We're going to destroy the session and remember, forget you, right? We don't know you anymore. We're going to throw out that cookie, it's invalid, right? And I'm going to sign you out, okay? Update user also, we need to be careful, right? Because if we do update the user, if we do update the user, we want to make sure that also the user in the session is updated, right? So if I change my email, if I change whatever, right, I want to make sure that the session. Now, this is if I'm updating me, right? Which is fine because I should only be typically I should only be able to update myself, right? Which is fine, right? But this update user, yeah, only works if it's me logging in, updating something about myself, but it's not powerful enough if I want to update any user. Like for instance, system administrator should have the capability of updating another user. I'm logged in as one person, but I am updating another user, somebody else's email, somebody else's whatever, right? So this code would not work for that because this only works for the current user. I'm updating myself. So the session information would change because I'm logged in and I'm changing something about myself. So if you want to expand on this and be able to support multiple users or one user being able to modify some other user, this code would need to be massaged a little bit better, right? And so now the because these because now we're using session on the server, right? That we're using these cookies. The client by default, Axios, right? All these requests that are going out for signing in and signing up and all that were going out and in the in the posts and the puts and whatnot. In that case, we were not using the session just yet. Okay, it was updating that one single current user. But now because we are using cookies on the server, right? The client also now needs to also use cookies, right? Now, Axios by default does not use cookies, right? Out of the gate, Axios doesn't even look at the header, the cookie header, right? So we also need to make a few changes on the client as well. We need to turn on, we need to create an Axios which will support the cookies, right? And add the cookies in the header, right? The current Axios implementation, if the server comes back with a cookie, Axios is just going to ignore it, okay? So let's create an instance of Axios which does participate in the cookie protocol, right? So to do that, right, we in our client, in our React client, right? Right now, this Axios implementation doesn't know what to do with cookies. So what we're going to do is that we're going to create an Axios with cookies or Axios with credential, right? That uses the Axios, same Axios library, right? But it creates an instance that says, hey, I am going to be using you to authenticate, right? And so yes, you need to support cookies, right? So now this version does support cookies. I'm just going to replace every single instance here of the Axios library. I'm going to replace it with Axios with credentials. So Axios now, right? I'm using this brand new version that does include the cookies. Okay, that's it. That's all we need to do. Just replace that, and now we should be able to support multiple users. Login as one, login as another, right, and whatnot. Okay, so let's try it out. So let's so the server's restarted, so I need to sign up. So let's sign up as Bob 123. Sign up. So I'm logged in as Bob. So on my Safari now. So let's put this on here on the side and let's bring a Safari. And so same thing, copy that like that. So profile. So I'm going to sign in as Ada now. Ada, 123, sign in account. So notice that I am logged in here as Ada, and Bob is here. So notice before when I refreshed over here, right, I would get Ada here as well. But notice if I refresh now, I am refreshing, yeah, and I get Bob, right? And over here, if I refresh, right, right, I get Ada. Now they're both independent of each other. Right? If I refresh, right, right, each one has its own session. I can have multiple users logged in simultaneously, each one modifying, their courses, their modules, their assignments, their quizzes. It's all now mapped to that session information, right? About Bob either being logged in or Ada being logged in, right? And because it's part of the reducer, right? All screens are aware of the current user that is logged in, right? And is being maintained on the server, not on the client. Okay. All right. All right. So let's talk about having access to all the data, right, that we have moved from the client, right? We've moved it over to the server, right? We have moved users, right, courses, modules, enrollments, right, and we've created a database, right, on the server side, right? So here it's implemented, right? On the server side, we have a database, not really a database. It's just a one big object that includes several arrays that represent courses, modules, and whatnot. But on the server, but none of these is accessible to the client, right? Still, the client, if I log in, is still using the database on the React web application, front end user interface application, right? So we want to replace, right, all that data that is currently in the React side. We want to replace it with data that is being hosted on the server, right? So, what we're going to do is we're going to follow the same strategy, right? Whenever you have a new data set, either a new table or collection or array or a new data structure, right? We want to implement all the various CRUD operations, being able to create instances, update, delete, and retrieve, right? Instances of that data structure. And for that, right, the pattern is to implement a DAO, a data access object, right? That it implements all the CRUD operations for that particular data set. Okay, so let's do that. So in the Kanbas, right, we have users. Now we're going to have courses DAO, right? That is going to import the database, quote unquote database, right? And it's going to implement all the CRUD operations, right? Find all the courses, retrieve a specific course, update a course, delete a course, create a new course, right? So all of them by manipulating the database, right? So yeah, so that's courses. Then we're going to expose all those operations to the client, right, through routes, right? So we're going to have a routes here, right, that is going to allow me to use the DAO, right, and make the courses available. So here it is, app.get API courses, right? Again, following RESTful APIs. This is going to retrieve all the courses because there's no primary key. It's a get, it's a plural noun, right? So it's following all the RESTful API conventions, and it's using DAO to retrieve the courses and respond with the courses. Perfect. So now on the client side, actually, let's first load up this brand new route into our server. So let's import our courses routes, right? And then register with app. So on let's see. Oh yeah, so we have many more CRUD operations, right? Retrieve the courses for the enrolled user, right? So yeah, in one case, we want to retrieve all the courses. Like if I want to enroll into the courses, I need to be able to display all the courses, right? But also, depending on who am I logged in as, right? I want to be able to see only those courses for the person who's currently logged in. Yes. So yeah, so that's another operation that we need, right? Find the courses for that specific user, right? So in courses, let's also implement here, find courses for enrolled users. So I'll give you the ID of the user, right? And you're going to find me all the courses on that for which that user is enrolled in, right? So I'm going to filter those courses, right? Only the ones whose course matches the ID of that course, okay? And I'm going to make that available in the routes also, right? And so now depends where I want to put this, where I want to implement this, right? Now I could implement it in different routes, right? We can implement it in the courses routes, yes. But I've decided to implement it in the users route, and my reasoning here is that the API starts, logically starts with first knowing who the user is, and then asking the courses of that user, right? And it's a hierarchy of the data of the whole data. First, there's all the data, and then you have kind of buckets that have a one-to-many relationship, right? Where um, usually you want to know, if you know the user, then you want to know more about the user, right? So the user, and then want to know, well, what courses are they enrolled in? Notice that the inverse is also true, right? That I can first know what the course is, and then I could ask, well, who are the users that are enrolled in that course? That's a legitimate question, right? Because these are many to many uh, um, relationships, right? If I tell you what the user is, I can ask you what are the courses that that user is enrolled in, and vice versa, right? If I give you the course, I can then ask you what are the students that are enrolled in that course, right? Uh, so so it, so if the question is, here's a user, what courses are they in? I think that logically it should be implemented in the user's routes, right? Because the route would start as, well, tell me first the user identity, and then I'll tell you what the courses they are in, right? Anyway, um, that's how I thought that made sense. If you prefer implementing all this, because we're retrieving courses, really, if for you it would make more sense for this to live in the courses, go ahead, and move it there. But I'm going to go with this. Feel free to re-architect this, right, and implement it in the courses if you find that to be more logical to you. Okay. Uh, so yeah, so let me in the user routes, right? I have the user DAO, right, that manipulates users, but now I'm also going to have the courses DAO, right? Because uh, there's two things here, right? I want to retrieve the courses, right? So I need the courses DAO because the courses DAO is the one who retrieves data from their data source. But then, right, this lives in the users because it's a user ID, right? So yeah, so let's implement find courses for enrollments. Let's look at the implementation. I'll put it down here. Here we go. Which I'm going to encode the user ID, and then I'm going to retrieve the user ID. If it's if the ID is current, right, meaning from the client, doesn't make sense for me to even give you the ID, right? Because the server already knows who's logged in, right? Would I need to provide you with an ID at all? Because the server knows, hey, you're logged in. I know your user ID already. If you're giving me an ID, then that means that you might be asking the courses for some other user, right? Right? Maybe I'm a system administrator. I'm logged in as a system administrator. I want to see the courses that you're enrolled in, right? And so my user ID is different than your user ID. So if you're giving me, current user, then I'm not even going to pass you the ID because you already know, right? So you actually, I'm logged in, and so you can retrieve my ID from the current session, right? And so if there isn't, right, if there isn't nobody logged in, I'm just going to kick you out. It says no, you don't have any access. You're not even logged in, right? But if you are logged in, then I'm going to retrieve the user ID from the current user ID, and then I'm just going to go find all the courses for that specific user, right? Now, I could give you another user ID because I'm a faculty. I'm looking at the courses that you're enrolled in. I'm a system administrator, so the user ID might be different, right? Because you're a different student, right? And I'm a system administrator. So the ID would be for your user ID, not mine, because I'm logged in. I'm inquiring about you, right? So this would allow you to, be used for both cases, looking at my courses or looking at your courses, right? But I'm logged in as someone else. Okay. Yeah. So now in the courses client, so on the client side, we can fetch the courses from the server by implementing a client. So in the React side, we can create a client, right, that can go fetch this information from the server, right? Oops. So I'm going to use Axios. I'm going to go fetch for the courses, fetch all courses. So this is for fetching all courses. Now, for fetching all courses, for instance, I don't need to be logged in, right? And because it's all the courses. Now, if I'm asking for the courses that I'm enrolled in, then yes, I would need to be logged in. Yes. So for this case, I'm not asking. If notice, I'm not using the Axios with credentials. So we could use this. Um, yeah, fetching all the courses to to display in the dashboard. Now for my courses, again, because this is specific to me, right, I'm going to implement it in the account clients because this is very specific about the current user, right? So I'm going to copy this and add it to my current client on the account, right? So current me, and get the courses, right, and then display that in the dashboard. So in the Kanbas, what we're going to do, instead of using the database, we're going to remove that, and instead we're going to use the client we just implemented to fetch for the courses, right? So for instance, in our Canvas, if you remember, right, we were using the database to populate, right, our courses, starting with these courses here, right? So we're going to cancel that. We're going to remove that and instead use our client to retrieve my courses, right? So what we'll do is that we're going to set the courses to be empty at first, right? And maybe you declare this as any. And what we'll do is that on load, let's see, first we'll retrieve the current user, because remember, we can't go into the dashboard unless we're logged in. So we'll retrieve the current user using a selector from the reducer. Once we have the current user, what we'll do is that we'll go fetch the current my courses for the current user, right? So let's do that. So let's do that. We'll have to import the use effect. So what does this do? So onload is going to call fetch courses, right? And fetch courses is going to go, find my courses, which is going to do a request get, current courses. And now that I have the courses, I'm going to set the courses using the state variable, right, which is currently initially empty, but from the server, I'm going to get my courses that I am enrolled in. Otherwise, I'll get a console error. Right? So um, in the dashboard, no longer do I need to filter because the filtering is happening on the server. So in the dashboard, I no longer am going to use the database, no database. And no longer I'm going to use the enrollments from the database. Okay. Instead, and I'm not going to filter, right? Because again, all that filtering is happening on the server now, right? So I'm going to remove this filter here because the server's finding all that for me. So now let's try it out. Let's log in. I guess I'm still logged in as Bob. Let's sign out and log in as someone. Let's see, someone who we know has courses. So let's see, enrollments. Let's see, we have 123. Who is 123? 123 is Ironman. So let's log in as Ironman and start 123. Sign in. There we go. So we're getting rocket propulsion aerodynamics for Ironman, right? If I go to account and I sign out and I log in as, say, Dark Knight and Wayne, and so I get the same users. Actually, no. Let's see. What are the enrollments we have? Okay, so let's do 234. Um, let's enroll someone else on this, or some other course. Let's see, 234 is also enrolled in, say, so this is 10. Let's enroll them also on RS103. There we go. So let's log in again and sign in as Dark Knight. Dark Knight and Wayne. Yeah, so now Bruce Wayne is enrolled in these three, whereas Stark is only enrolled in two. There we go. So it's enrolled in just two. Make sense? Okay. All right, how about creating new courses, right? Say, for instance, I'm a system administrator, right? I log in as Ada, for instance. She's a system administrator. She wants to be able to create new courses, right? So let's do that. So in the DAO, right, we can implement create courses in the DAO for the courses, right? So here's a create courses. With a brand new unique identifier, it's going to append the new course at the end of the array of courses, and it's to return the new course. And then in the also we're going to have an enrollments DAO. It's going to maintain the enrollments on the server too. So let's do that. Enrollments, Kanbas, new enrollments DAO. This is going to instantiate a new entry in the enrollments where it associates, right, a user with a course. It's going to make an entry in there. And then we're going to expose in the routes, right, to when we create a new course. Again, I implemented this inside of the user's routes, right? And it might be more intuitive for you to implement this maybe in a route for the enrollments, maybe, right? I thought it would make more sense in the users because, again, for enrolling, you need to say you'll start with the users, right? And say, okay, which user are you enrolling in which course? Okay, and so, right, and because you're creating a brand new a course, when you create the course, right, you're going to have to create an enrollment for that user, right? So I thought because it starts with users, it made more sense to implement it in the users. If you think this makes more sense to live maybe in the courses route or in the enrollments route, then go ahead, implement it there if it makes more sense to you. Right, so let's bring in the enrollments route, right, for the users in the users routes. So let's implement, here are the enrollments DAO and create new course, right? It's going to be a post of creating a new course. So I'll put it down here. There we go. So it's going to grab the current user, right? It's going to create a new course from the name and description that you provide from the user interface. Is going to enroll the current user into that course, right? And then just respond with the brand new course, right? Now in the account client, we're going to post this new course for creating it, right? So, but this time around, we are going to use Axio's credential because we do want the server to remember who's currently logged in. It's going to be able to pull in the ID of the current user because it's going to enroll that user into the course, and the server does remember who we are. Right? So in the account client, account client. I'm going to create a new course. We're going to post the new course. You're passing the title and the description, right? So here in the add new course in the Kanbas, right? Instead of updating the local database, right? We're going to use the user client to create the course remotely. Right? So let's copy that in the Kanbas index. We have the add course. Where's our add course? Fetch course. Yeah, just add new course. The initial implementation was to update the local state variable, right, with this new course. But now we're not going to create the course. The server is going to create the course. We're just going to get the new course from the server, right? So let's replace this and say, the server is going to create the course. We're going to get the new course from the server. We're just going to append it to a local state variable, right? But we're just a copy of the remote state, right? Let's see. So let's try it. Let's try it here. Let's log in as Ada. I'll need to be an admin. So Ada 123, sign in. So now we can create the course. So we can say new course 123, a new description 234, add. And I don't know if that worked. Let's see, inspect. I don't believe it worked. Am I logged in? Am I still logged in? I am. Let's see, resource, source network. Let's see if we get an error. 123, 123, add. Okay, that didn't work. Let's see, the server's complaining. Let's see the server log. What is it complaining about? Error reference unit is not defined. Oh, okay. So that's in courses DAO. Okay, let's go courses DAO. Okay, it might have been that I did not install UUID maybe. Did I not do that? I thought I did. There's a server DAO. Okay, there it is. Right. So let me import. I just didn't import it. So here, let's import it. There we go. And the server should have restarted. Okay, restarted. Okay, so let's go back and let's log in again as Ada 123, sign in. Let's clear that. And let's create course 123, add. Okay, so it creates course 123. There we go. If I refresh, notice that it remembers that I'm still logged in. It still fetches the courses that I just created. Obviously, the ones that I am enrolled in, right? And that's all maintained on the server. It's no longer maintain anything on the client. The server becomes the single source of truth, and eventually the database will become the single source of truth, right? So that is what we're going to do next lecture, right? And finally, let's take a look at maybe deleting a course, right? So for deleting a course, right, we can implement in the DAO, because the DAO is the one responsible for manipulating the data structure. So in the DAO for the course, we can create course, find the courses for enrollments, or remove a course, which is basically, again, using the local database, finding the courses with that ID, right, and then removing that course from the courses and removing all the enrollments for that. If the course doesn't exist, anybody who was enrolled in that course, right, loses the enrollments. They're gone, right? And then in the routes, we can expose this. I'm going to implement this in the courses routes, make more sense there. So courses route here, we're going to send an HTTP delete, and I'm going to say delete the course, passing the ID of the course. Again, the reason I put it here is because the API starts with courses. And that's how I'm thinking, in which route it goes, right? If it starts with the user's route, then I think it would go in the user's route. If it starts with enrollments, then enrollments, right? So it depends, right? I think that was made logic to me. So delete the course and then returns the status saying whether it was successful or not. Right now, in the client side, we're going to send the delete from the client, from the React, from the courses client here. We're going to send a delete. in the ID of the course that I want to delete, and we're going to invoke it, from the delete handler in the Kanbas, right? So the Kanbas, here we have a delete, right? There it is, right? That does the current filtering. But we're going to replace that with the server. We're going to bring in the use the course client that has the implementation of that delete, and we're going to update the delete, right, to do it on the server, not locally, right? So the server is going to do the delete. So what we're going to do is that we're going to first delete from the server, and then we're going to delete locally from the state variable, right? So that again we keep it in sync. I don't believe we need the status, so we can just do a wait. So this is going to remove it from the server first, right? And then locally, to be in sync, right? We're going to make sure to remove it also from our local state variable. So we're going to do the same operations. Another way we could do it is that once we remove it from the server, we can ask for the server, hey, give me all the surviving courses. But I think that's too expensive. I mean, it would be an entire, huge array of courses. I already have a cache version of that array of courses. I just can manipulate it in both places, right, and be in sync. Okay. So yeah, so let's try it. Right. So if I log in, and so for instance, as Ada, let's create a couple of courses. Sign in failed. No, is it 1, 2, 3? Uh-oh, what happened? The server crash? Okay, yeah, server crash. Let's see what's going on. App is not defined, blah, blah, blah. Uh-oh. App is not defined. Here, delete, yada, yada, yada. Oh, I put it outside of the function. This needs to be live here. There we go. All right, so let's try it again. Log in as Ada. Okay, I'm logged in as Ada. Let's create a couple courses and see if we can delete them. Add. Let's add another one. Add. Add. And let's make sure that they are stored in the server. Okay, if I can refresh, it remembers who I am. It retrieves the courses that I have, and because I'm a system administrator, I can delete. So I can delete this one. Let's see if I refresh. Notice that yes, it was removed from the server, and I also removed it from the user interface. Perfect. Okay. And finally, can we update a course? Right. So for instance, in the DAO, I'd like to update the local on the server instance with the changes that you might send me from the user interface, right? So from the node server in the courses DAO, so in the courses DAO, let's implement update, which is basically finding that course and applying the changes that you're passing me the updates, applying them to that course instance, right? And then returning the changes back, just to verify that those changes did take effect, right? I will expose that API in the courses route, as a put, right? In the courses route, here's a put. Oops. Again, it needs to be inside of the function. Careful. And so I'm parsing the API, the ID of the course from the params, right? It's encoded in the URL. The updates, I'm going to pass them in the body of the request. And then I'll use the DAO, right, to apply those changes to that course by its primary key, and then respond with a status 200 if it's successful or not, right? And then in the client, right, in the courses client, I'm going to send you my updates. I'm going to put them to the server, right, with the ID and the changes. I'm going to send them over to the server, and the server will apply those changes. So on the client, in the courses client, I'm going to send an Axios put, right, with the ID and the updates, right? And in Kanbas, when we update, right, we're going to maintain the local update in the local state variable, but I also am going to notify the server of those changes so that, again, we maintain in sync, right? The changes in the server, but also the changes locally on the user interface, right? So let's just add that to the update courses in the Kanbas. So in the updates, right, I'm going to maintain this. So this stays, right? So these are the changes that, modify the local state variable in the user interface. But at the same time, I want to make sure that I also make the changes in the remote server. Oh, it looks like here I'm expecting to pass the course. So I think this would be course ID. Yeah, so this is supposed to be course dot underscore ID. There we go. And well, actually, let me copy because this is the update of the course that's already in the state variable. I shouldn't need to pass the ID. Course update course is because when I'm editing, right, it copies it to the state variable. I shouldn't need to pass the ID. But I guess this was written to pass the ID. I should not need the ID. See dashboard, update course. Oh yeah, it does pass the ID, but I shouldn't have to. Let's see. I'll copy this implementation. Maybe I implemented it that way on my own. Let's see. Let's see if it works. If I refresh, yeah, let me log in again. Ada 123. Create a course. Add. Refresh. Let me edit this. Okay, so it copies it there. So including the ID. I shouldn't need to pass the ID. Let me change this to something else. That. Save. And let's see the save. The headers went out. The payload, the changes, they were, yeah, the changes made it. So that if I refresh, yeah, the changes took place on the server and on the client. Right? So if I refresh, right, it refetches it and the changes take effect. Okay. All right. That's all I had for you today. Um, let's take a short break and then we'll do office hours. Okay. I'll be right back.
So, can you see, this is like the
Yes, I can
thing.
see. Yep.
So, right now I have the quiz list and then the detail screen and this detail editor, and this question editor. And then,
Nice.
yeah, so my question is now I can actually, like modify like anything in this quiz. Let's say I have like 50 points now. And
Perfect.
then let's save the question, and now it show up as 50 points for this particular quiz.
Very nice. Yep.
But how do I modify these points up here?
Right. So, I mean, you're iterating over the questions, right?
So let me see. Uh so for this whole so it's for this whole like page, it would be like it would be a tab, right? And then
Yeah, I know, but what I mean is that the question one, two, and three, you're retrieving that from some reducer, I imagine,
right, right.
right? And you're iterating over all three questions, right? And displaying the points for each. I mean, wherever you're displaying the points, the total points, um, that number should be taken from iterating over the array and accumulating the total points, right? From the same reducer. So where are you rendering those points, the total points?
So right now, this total points is from, let me see, should be in here. So for the quiz slice, I have this points, like in this object, I have this points field, right? So this
Um,
is where this is rendered from.
oh, okay. So I think I don't know if you want to store that as the total points here. because then you'll have a redundancy of how the points are accumulated, right? It could be
Mm,
either here or the accumulation of all the points for each one of the questions, right? Um, so so I would not maybe have it here. The point should always be the accumulation of all the points of each one of the questions, right?
oh, okay. So you're suggesting I should not include the points
Yeah,
for
because
each.
otherwise then you would have to make sure that those two are in sync always, right? It would make
Yeah,
no
yeah,
sense for
yeah.
this to be 40, but then if you add up all the questions, it comes out to be 50, right? Uh,
Right, right.
so then you would
Okay,
have to make sure that those are always in sync. So
okay,
maybe
okay.
this don't put this in this slice, but the total points would always be the sum of all the points of all the questions.
Oh, okay, okay. That makes sense.
Yeah.
Thank you. Yeah. And then another question is when I try to modify the list of possible answers, right?
Hmm.
So if I don't know if so my problem is that I don't think I have shown it here, but when I click this
Hmm.
and it should show like a correct answer, right? But when I maybe modify this array of possible answers, um, and right now I guess I'm using the index to indicate to remember uh which is the correct answer. But I guess that's not a good idea because if I modify this array and index change for the correct answer, it will
Right,
return
right.
different.
Yeah, no, you should have like a either a checkbox that allows you to choose which one is the correct answer.
Okay, okay. And then
Or say that when you create it, it's always the first answer, but then when you display it, it's always random. I mean, you could do that too, I
oh,
guess.
okay.
But when you create it, it's always the first answer is the correct answer, but then when it's displayed, it's random. Although I would prefer, yeah, like that you would
Yeah,
have a
yeah.
checkbox that
So
says which one is the correct answer.
right.
Also, you could have multiple correct answers too, right? Oh no, you're not doing that. Sorry, multiple choice only has one right answer.
Yeah, so I guess I don't know. Yeah, see, if I delete this, it will always show the third one, like the index two as the correct answer, right? Even though let's say this is three and this is four, this is one, this is two. And then
Right?
I delete this, but then it will show up two as the
Yeah, no, it
correct
should not
one.
be the index. Right. It shouldn't be the index. The answer instead of having the index, maybe the answer should have a feature on whether it's correct or not.
So, or maybe, what I thought is that maybe I should give each answer an ID and then mark that particular
Yeah,
answer.
that could be two. That could be two. Or, right, you have the value of two is being stored somewhere, right? And that could be stored along with the object that stores the correct value or the correct answer to could also have a Boolean property on whether it's correct or not, which you can toggle, right, when you click on correct answer or not, right? So when you
Mm,
render these, right, as you're rendering them, whether you had stored it on whether it was true or false, right? It'll render the checkbox will render depending on what this property of whether it's correct or not, the value of that is.
okay,
Yeah,
okay,
it's different ways of doing the same thing.
okay, yeah.
If
I
you're
have
using
thought
an
about
index, then you'll need to update that index.
right, yeah. Yeah, I have thought about that, but like my concern is if there are duplicate answers, then then I don't know if we should check. Like if we don't allow duplicate answer or not. You know what I'm talking about? Like suppose like we have the same answers, and then if I store the two as the correct answer, then I don't know which one should I mark it as the correct answer. Does that make sense?
Um, Wait, can you say that again?
So like if I do it only storing the value of this input box, right? That's the correct answer. Then what if there are multiple uh like the user input the same um value for multiple
Right.
uh accepted answer, then like they are all
Well,
two.
right, no, but I mean that's the user's problem, right? If they put the same values in all three or four, right? That's irrelevant, right? You select the index or the you maintain some other data structure telling you which one is the correct one, right?
Yeah.
Okay. You're saying that it'd be you just say the correct value, which then gets compared to the correct value.
Yes. So
Yeah, no, but
if
then you have the problem of what if you select all the same values in all of them, right?
yeah.
Yeah, no, 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 no. Yeah, don't put the correct value. Say which answer is the correct one.
Okay.
Yeah.
Okay then. Yeah. Okay. I will stick with the ID one, I guess it would be more straightforward.
Okay. Sure.
Sounds good. Thank you so much.
Sure. Good luck.
Thank you.
All
Bye.
right. Bye. Good night.
You too.